Hi everyone, great to be back at DappCon. I think I've been here most years since my first presentation in 2019, so always glad to be back. Audience is growing, I like to see that. Last year in the bear market it was still fewer people. Today I will be talking about Ethereum Layer 2 interoperability, and specifically not just interoperability for the sake of interoperability, but actually we believe it enables a whole new sort of class of smart contracts to be built, which we call infinite, horizontally scalable Web3 applications or smart contracts. And I will be diving into what that means in a moment. And it's actually quite timely. Vitalik, the man himself, tweeted today about Layer 2 interoperability, emphasizing how necessary it is, and sort of also talking and promoting a bit that we need like standardized systems and we shouldn't build too much sort of isolated system in the industry. And so I just want to plug that in because I think it was quite timely. It was like 10 hours ago. And if I want you to get anything out of this talk, then it is sort of this concept, which I would sort of classify as a pretty bold claim about the future of how you build Web3 applications. It might not actually end up like this, but I think there's a strong likelihood that this happens. And the first one is that apps actually won't build on any shared blockchains anymore. And this you might have heard from like the application-specific blockchain hypothesis, right? It's fairly similar, but I want to take it a bit further and actually say applications won't build on a single blockchain. You will have applications that build on multiple horizontally scalable and interoperable virtual machines. And these virtual machines, i.e. these layer 2s, they will scale elastically, so they can be created and they can be destroyed. And with that, you can actually horizontally scale applications to the world, like we do in Web 2. And this requires a pretty big shift in how we think about smart contracts and designing them. We need to think of smart contracts as modular systems and not sort of monolithic systems that are based, the way the state is based on a single chain. That's me, I'm Hilmar, one of the founders of Gelato. If you don't know what Gelato is, we're building Web3's cloud platform, and we try to enable developers to build verifiable, horizontally scalable blockchains and applications with a bunch of really powerful Web3 services. So at the core, it's a rollup as a service platform where we host layer 2s, all the optimistic rollups, ZK rollups that you know. We try to make them as interoperable as possible for you. You can have multiple layer 2s that you spin up concurrently. We want to provide you with shared sequencing on top of that, so you can have higher guarantees, atomic composability between them. And on top of that, we have a bunch of really valuable Web3 services that enrich these applications with off-chain data, verifiable randomness. You can abstract complexities like gas as well. So we provide you with all of that on a single platform. And we've got a bunch of really awesome chains that are already live with us, from Asta, the first Polygon CDK connect to the Egg layer, to Liz from the OP Superchain, to Rhea, the biggest perp application, application-specific perp DEX on L2 that actually trading went live with them today, which is super exciting, and many super exciting ones in the pipeline, so stay tuned. But yeah, let's jump right into like the more technical part, which is, this is sort of how the layer 2 landscape looks like today. So you have a bunch of isolated layer 2s, where each layer 2, this is sort of changing slowly now, mostly has their own individual L1 to L2 canonical bridge. This is of course not optimal because you might want to aggregate assets into a singular sort of bridge contract, so you don't need to move them on L1 if you need to rebalance, if you want to move assets that are originating from L1 between L2s. Then you have monolithic layer 2s that are not communicating with each other, or they are communicating but with third-party validator cross-chain messaging protocols in a very sort of high latency environment. And then you have sequencers, or you can think of sequencers as block builders, that are building the blocks, so ordering the transactions of each of these L2s in a way which is super isolated, and so one sequencer doesn't know what the other sequencer sees on his chain or another one. So it's very isolated, everything. And if you're building an app, you sort of say, OK, I either want to build my app on L2.1 or on L2.2, or I want to build my app on L2.1 and 2 and 3, but they never communicate to each other, so you just replicate them. So yeah, it all doesn't really make sense that much. And on top of that, these chains are already struggling to scale, right? Chain scale via cheap sort of computation and data availability that they can access. This is already, it has some pretty good progress with like 4844 and Celestia and all the other DA layers coming up. But the execution environment, the VMs are actually getting the bottleneck. You see this with Base really like hitting it off sometime in March, and it spiked tremendously. And so VMs are already becoming the bottleneck for these chains. And if we really want to do mass adopted, if you want to build applications that have millions of users, then our current VMs are just not enough. You can build parallel VMs, but at some point they also sort of end in terms of the performance increase, right? And if you're building on Base, let's say you are just building an application, but suddenly there's this degen NFT that consumes all the gas. Obviously, you're out of luck, and your user experience suffers a lot. And you can't just migrate to another chain, right? You're kind of like stuck. The state is stuck on that chain, and so yeah, you can't really do anything. And so how we can solve this from like a technological point of view, from like architectural point of view, is by having more shared systems between the different L2s and having standardized systems. So firstly, what would be great is having like a shared layer 2 bridge where everyone can deposit their assets into on the L1, and then each L2 can sort of derive what assets it has based on the assets that were locked into the bridge and some sort of pointers that are in there. And the cool thing is if you want to actually move assets from one chain to another, they don't have to be moved on Ethereum by the transfers. They just sort of, you update it with the Merkle root, the different balances. Then we need communication, trustless, Ethereum-grade communication between the L2s via a shared interoperability protocol, which I will sort of discuss in a moment how this can be designed from like an optimistic rollup point of view. And then shared sequencing, what it enables, if you combine it with interoperability, it brings you atomic composability. So you can say, rather than crafting a block for layer 2 number 1, you can say, I craft a super block for layer 2 number 1 and layer 2 number 2, and the block is only valid if transaction A was included here, then B here, and then C there, and then D here again, right? And so you can sort of atomically execute transactions between them. And the cool thing about this, and this is sort of what I want to bring home at the end of the day, is you can build applications that sort of change state and move from one chain to another and sort of evolve dynamically with new chains being spun up. So I will talk a bit about the optimistic rollup design and how we can achieve it here. A lot of research has been put into this, especially for like the OP Foundation. Arbitrum Orbit is also working on this. Polygon is working a lot on the ZK side, and I know I'm really bullish short term around the optimistic rollup side. Vitalik posted today that hey, in 10 years it doesn't really matter, everything will be ZK, but I think the emphasis here is in 10 years, right? So I think there will still be a pretty sort of long period now where we will first dive into optimistic rollups and everything. And so some definitions first. What do we want to achieve here with this interoperability? We want users to be able to submit transactions on chain A, and we want this sort of information to be transmitted to another chain. So this chain B should be able to read from chain A. There are also other things you can do, like chain A writes to chain B, but this is a bit more complex, out of the scope. And then there's an initiating message on chain A that the user sends, and then there's an executing message on chain B that like the user can send as well, or a relay, or anyone really, a block builder can include it. And then chains can control which other chains they actually will allow to communicate with. So if you're a chain, you can say, hey, I allow chain A, B, C to send executing messages to my chain that I have to verify. And this is sort of like the high-level process of how this works. So what you can do is you can have, let's say you have OP stack, rollups, right? And you have, let's say, 5 of them. You will pre-deploy standardized cross-chain messaging smart contracts on all of them. It's very similar to like any cross-chain messaging protocol here. This is a pre-deploy. It doesn't have to be pre-compiled, so you can just like do it on the fly. You don't have to deviate from the standard EVM. And then you as a chain owner, you can say, hey, maybe these 4 chains that I will whitelist in my dependency set, maybe they're my chains, right? And so I have a pretty high trust in these chains that all the sequence transactions are actually sort of like conform with what I want to achieve. But maybe you also have, maybe you also trust some other chains, right? Maybe Base or OP mainnet, you want to integrate with them, so you whitelist them. And then what happens is that, let's say there's a transaction on a chain, relayers will sort of get paid or incentivized, and relayers could be block builders at some point, to then submit transactions which originate on other chains to the sequencer of, let's say, our chain, our home chain, and they will point them to an identifier that enables the sequencer to say, that enables the sequencer to find that a particular event that was emitted on the foreign chain. And this consists of an event index, chain ID, address. And then the sequencer will be able to validate whether this event was actually happening on the other chain and will include it into his own chain, the executing message. If the event was not emitted on the foreign chain, then he will discard, or she will discard the transaction and reorg out, so it won't be included. And the whole system is actually not secured by some external validator set. It can be fully secured via Ethereum using a multi-chain fault proof. And what it means is that rather than you having to prove that the state rules that you're publishing as a sequencer to the L1 from your own chain are correct, you need to now prove that the state rules published to not only your, but all the other chains with the dependency set, and potentially also the dependency sets of those have been done correctly. So yeah, it becomes much more difficult to actually build these blocks. This is more like a diagram on how this looks like. It starts at 0 here, so user sends a transaction to, let's call it base. Then relayers will listen to this and send an executing message using the data that was emitted here to my chain, right? This is the Hilmar chain right here. It listens, it has base as a dependency. What I now need to do as a sequencer is I need to verify whether this was actually emitted here. And if this was emitted here, I will include it in my batch that I post on Ethereum. And then once I post my batch to Ethereum, anyone can go in and actually check whether this event was actually emitted here, and if not, can submit a fraud proof to potentially slash my stake. This, as you can see, makes it much more difficult to become a sequencer, right? Because you now don't need to be only aware of this chain, but also this chain, this chain. So you need to be quite careful which chains you add in your dependency set. And these machines will be beefier. But I will go into some trade-offs in a moment. So the great thing about this design is that there's no force inclusion, meaning you don't have to sync all these chains together. Why does it still work? Because we actually, rather than having like an in-protocol rule that all the transactions that have been emitted need to be executed, we outsource it to the block builders, right? We can say, hey, events can be emitted, but only if someone really incentivizes you to relay that transaction on the destination chain will block builders actually come in and do this. And this is cool because we don't have to, like in Ethereum with withdrawals, we don't have to implement some queue system, and we don't all have to sync all the chains together. We can all have them run asynchronously, independently, and let the block builders really handle the scalability of this. If you combine this with shared sequencing, you can actually get atomic composability if the block builders have sort of monopolistic power over building blocks between one chain and another, and then you can have transaction A that originates here, relay to B, then back to A, then and back to B here, and then you can have some sort of flash loan potentially even. And yeah, this all works with like a multi-chain fraud proof, so there's no additional trust assumptions in the system. Some cons of this, it leads to centralization, so basically Wintermute will build all the blocks, right? But they kind of already do. And it only works for certain optimistic frameworks like the OP stack. It can also work for like the Arbitrum Orbit stack or other stacks, but it is very difficult to make cross-framework right now. And of course, it would be great if we can all do it cross-framework. But this, unfortunately, is a bit harder. But there's also some solutions to like the centralization of block building, like Verkle trees and stuff like this. It just makes it much easier to verify the state of other chains, right? But this is all a couple of years out, unfortunately. So now, an example that I like to use to sort of, now this was the interoperability part, right? But what about these new smart contracts that just like scale, right? How are these actually being built? And so let's imagine we have a perp DEX. And let's imagine this perp DEX actually consists of 2 chains. One chain has all the assets in the world that are traded against USD, and then one chain has only ETH versus USD that you can trade there, right? And because ETH USD is the highest volume pair with the most trades, it needs like its own chain to really sort of satisfy the demand of the users. And now what happens is that Paper, a meme coin you might know, starts really going crazy, right? And a lot of people want to buy and sell Paper, right? And the virtual machine of the long tail USD L2 really gets to capacity. What we can do is we can dynamically spin up a new equal virtual machine, being like a layer 2, and we can migrate the state of Paper, USD, all the assets, all the orders and everything. You can think of this as like an on-chain order book, to this new chain. And the users will just like sort of send transactions via like some API probably, and it gets routed always to the right chain. Assets can be moved freely between them. And now we have a dedicated virtual machine which only handles Paper USD, right? And now the system scales again, and everything works well. Let's say Paper volumes go down again. Now Paper, no one cares about Paper anymore. Everyone sold it. And we don't actually need this dedicated instance anymore. What we can do is we can, again, with like an off-chain worker that does this, that monitors like the loads and so on, we can migrate the state away from these new L2s back to the old one, to this general purpose one, where you can think of as like the hub, right? And we can spin them down, so we can deprecate these chains. And now we are back to only two chains. You see it's very similar to like horizontal scaling in Web 2. What do we actually need to sort of like build this out and make it work? We need to abstract away the complexities of managing state from developers across many L2s in sort of like this elastic, dynamic way. There are some ideas around this using distributed hash table libraries and so on, but yeah, this still has to be built, right? This is the complex part. We need these off-chain systems that actually like monitor the loads that these systems are getting, and the capacity limits, and then spin up new chains and sort of deprecate them again. We already have a lot of this at Gelato by having to service a lot of layer 2s in production that sometimes like get 10x the usage for an NFT drop in a moment, and we have to replicate instances and spin up new VMs and so on. But this has to really happen with like new chains that are then migrating states, so it becomes much more complex. And this whole system has to be done in a way where it sort of works well, it resets itself, it heals itself, right? Every time there's a new chain deployed and there's a new chain destructed. This probably won't work for all the applications, right? I'm not saying this will solve everything, but it will definitely, I see a lot of use cases like on-chain order books where you can split via pairs, or you can even split between pairs, right? Or you can have certain engines that only focus on deposits and only focus on sort of trading and liquidations on like different shards. But yeah, it requires a lot of additional tooling and has to be built. And yeah, of course, it would be great if we can harmonize it between all the different sort of clusters that are being built right now. I think Vitalik today said he's not really happy about having 5 separate solutions for 5 sub-ecosystems. That's needless fragmentation. This is kind of like what is happening today with all these ecosystems being built in parallel. It would be great if we can find like a harmonizing way. Probably something around like ZK proofs at some point will enable this. But yeah, right now, basically, we have these separate instances sort of being built. And I actually believe there will be many, many more in the next sort of year or so. Yeah, I think that's already it. If I want to bring one point across, is this sort of new way of building smart contracts, not on one chain, but you have 10 chains behind a single application. And yeah, we are sort of experimenting with this. And so if you're interested in building, I don't know, the next Binance on chain that really needs infinite horizontal scale, reach out to us. We work together with a bunch of cool projects that are having similar sort of ideas. And yeah, thanks a lot for listening.
Thank you, Hilmar. We have a few minutes for questions here. Down in front in the blue shirt.
Hi, thank you for the talk. I actually have 2 questions, if I have time. So the first one is about the sequencer centralization. You touched on it already, that when you whitelist some chains in your dependency set, actually, you're kind of whitelisting the full dependency graph, right? Because these chains in the dependency set will have possibly different chains in their dependency set and so on. So does this mean that the sequencer actually, when they have to verify the inclusion of a certain initiating message, possibly that they have to verify the full dependency graph?
Yeah.
So which means that possibly you're not really scaling in a sense, like you scale with the number of chains in your dependency graph.
Yeah, you have to really be mindful of who you whitelisted is, right? You can't whitelist chains that have, I don't know, 100 different dependency sets to all sorts of random chains that you don't trust. So it has to be, especially in the environment where you have your chains interconnected with each other, you can really horizontally scale forever. If you want to use this to interoperable, like with foreign chains, let's put it, right, you have to be very selective. Otherwise, yeah, it grows in terms of the workload that you have to do and the remote chains you have to verify. And this leads to centralization of block building.
Whitelisting is also off-chain, like it's nothing on-chain, right?
Yeah.
In the future, they could whitelist someone else, and then you're kind of mindful for others. Let's put it in this way because you could.
Yeah. Okay. DOP, like how Optimism actually tries to solve this, they have like the governance, right? And they have this governance layer where they actually decide what to whitelist and so you will probably have these enclosed environments where you interoperate rather than just letting everyone go crazy.
Yeah, that makes sense, yeah. I have another question if nobody has another question.
Go ahead, please.
So this chain-on-demand approach that you presented where you spin up another execution layer whenever there is need for it, wouldn't it be simpler and maybe equivalent to just, let's say, increase the gas per block, maybe with some protocol to increase it for specific applications, but without spinning up new chains, without migrating the state, just having a more flexible, gas economy, let's put it this way?
You mean vertical scaling?
Yeah, I mean, in the same chain, the gas per block can increase dramatically. I mean, this cannot happen now. I'm saying, would it be equivalent?
Yeah, so it's vertical, like basically vertically scaling single instances, right?
Yes, in this sense,
yeah. So there are two approaches to scaling, right? Vertical and horizontal. Vertical has its limits eventually, right? You can't vertically scale forever. And so you will at some point hit a threshold that you can't go beyond. It will become also increasingly tougher to verify this particular chain for everyone else, right? Whereas, like, if you just want to verify this particular chain, everyone can still do it if they don't need to verify all the other dependencies. And so, yeah, in Web 2, you also don't have a single server for Amazon that has everything, right? Amazon scales horizontally, and there's probably a reason why we believe this might be the superior architecture.
Okay. Yeah. But in a sense, it's the same problem. Like, you're centralizing. That's the same trade-off, kind of, right?
Like,
that you get.
With today's block building and verifying everything will become more and more centralized. It is already happening, I would say, yeah.
Thank you.
Another question, the white shirt.
Hi. Thanks for the talk. I think you mentioned that in the example, the use case, but I just want to ask again, see if I understood correctly. How does it actually solve the liquidity problem that we have across layer 2s today?
Yeah, so basically, in this model where you have the native interoperability between multiple chains, you can spin up new chains and atomically move over assets in, like, I don't know, a second, a block or something, to the new chain and then conduct all the trading there. As soon as the chain is no longer required, you can reconsolidate the state back. And the state means the balances and all the assets, and i.e. all the tokens via like mint and burn mechanisms back to the other chain and then deprecate it. So it has native interoperability, i.e. native bridging in there. And then with the shared sequencing on top, you have composability where you can actually sort of do the mint and burn and atomically across different L2s. Yeah.
Any other questions out there for Hilmar? All right, give it up for Hilmar. Thank you so much.